Okay, which one of the following alkanes with formula C5H11Cl give the largest number of isomeric products itself when heated with this, okay? Now, the role of ethanolic KOH is for elimination, right? So like that. So what is the key criteria will be, you only eliminate, right? Eliminate Regan, any H or X that is attached to adjacent carbon. So let's say, for example, if there's two ways, right, then you have to, this lead to different isomers, right now. So when I talk about isomer product, meaning it can refer to being constitutional, okay? Sorry, you are here, so that's what I like about this layer, because when you are there, right, you will be shielded by the rolls of paper, but when I are here, I can walk everywhere. Okay, so it can refer to constitutional isomer due to different positions of the double bond, or it can be due to stereoisomer, like your C strands. Okay, I don't think there will be any enantiomer. I don't think so. Okay, yeah. So in the event that if you think, wow, what's all these things? Okay, so it's time for you to go home and recap on intro, because I cannot keep going back. I rather do new things, give your spend the time to revise rather than keep going back to the same thing right now. So I need a help. Okay, organic. If you don't, you always link back to the previous one. So now today we are at the 4th chapter, right? So you're going to add on. If you don't go and revise, you realize that when we are at next chapter, alcohol, you totally lost. Okay, so I need a help. Okay, next one. So in this case here, they ask you which one gives the largest number. So let's say we do one by one first. For A itself, you draw this out, right? Okay, because the Cl is on the first carbon, there's only one way we can do elimination, which is eliminate this one and this one. So we've created this. Okay, there is only one product that can form, and this product happens to not be able to fulfill the criteria for C strands. So I put a cross here because there's only one and one product. I know it cannot be the answer. Okay? Who is already lost? My dear John. Remember you promised you said read that you can. So I haven't answered your mommy yet. Okay, then option B. Okay. Option B, I also put a cross there because if we draw this out over here, adjacent to this carbon is this one, right? Is there any adjacent H there? Don't have. So for option B, there's no way it can undergo any elimination. Okay? So if they either want you to come up with a product, I would go with substitution for this one. In the event that if don't fulfill the structural criteria for elimination, then you go by substitution, which is not what they want. So I cross out A and B. Okay, so now we are 50% closer to our answer now. Okay, now let's draw C. Okay, so your C here, right? Your C here, right? Okay, your Cl is here. So I can eliminate like that Cl with this H here, right? So give you this, the one in red. Okay, the one in red, all right? John, can these exhibit cis trans isomorphism? What's the criteria?
Because for the
you want to help him out. Why this one can exhibit cis trans isomorphism?
This is got two same groups like each.
Number one, double bond, you cannot rotate, right? Then after that, to each of the alkene carbon, you must two different group attach it. Okay, I think that's what he means, but he left the keywords heated. You know what I'm talking about? You sure?
Wait, what do you mean by same groups? Is it because
different group? This each of the carbon, right, that form the double bond, right, must bond to two different groups. For example, this one, HH, right? HH, right? This one cannot see strands already. Okay? So what's the criteria? If you want to talk about what I call cis, then the same group must belong to the same side. Then trans to the opposite side. But before I can reach that stage, right, you must be able to fulfill the two criteria for isomerism, for cis trans first. Yeah, which is double bond, no rotation, right? Second one will be each of the alkene carbon bonded to two different groups of atoms.
So it is bonded to two different.
Yes.
Okay.
Yeah, it is bonded to different.
No, I thought you said it's not.
Yeah, it's two different groups. Okay, it cannot bond to the same group. Okay. Now, if you remove from from the one that I underline in blue, all right, it will look something like this, right? This one, right? Can this exhibit C strands, Braden?
No.
No, why no?
It's bonded to the same group.
So this carbon fail, right? Correct now, Song Yang also cannot. This one can, but this one cannot, so cannot. All right. So therefore, for this one here, how many isomers do you have? I have 1, 2, but here you should have cis and trans one. So you count 1, 2, 3. So total here is 3. That's why I put a 3 here. Okay, I pause. Want to take down anything? Please do. Is it okay? Can you, okay, I'll give you 1 minute, okay, or 2 minutes max, figure out, okay, for D, how many isomers are there? B, constitutional, the cis trans doesn't matter, just figure out for me option D. What option D lose out to option C? Can? No worry, how many isomers are there? 0?
0.
How many?
Not 0.
How many isomers are there for?
0, right?
Not 0. It's not 0.
After heating with ethanol.
Yeah, so elimination. So there is alkene form.
With 2.
2. You got 2?
Yeah.
No? Okay, Cradle, I see. Okay, look, you draw in different color coding, can? Okay, for example, you look at this. Adjacent to this carbon is this one, right? Adjacent carbon, adjacent to this one, right? That's okay. So double bond will be here, right? Can this exhibit geometrical cis trans? Cannot. Okay, so 1, all right? The other blue, adjacent to this carbon here is either this or this, which is identical. So I can put like that. Can that one undergo exhibit cis trans? Can that one exhibit cis trans? The blue one? No. So that's why 1, 2, like what John said.